Hi class, so this video is about the Gauss-Jordan elimination. I want to show you how to produce a reduced row epsilon form for a 2 by 2 matrix. So first, as you can see, we have a 2 by 2, two variables, so two linear equations, which is 2 by 2 matrix. So first thing we need to do is we need to write them as the matrix. So you just take the coefficient. Now, the goal here is to get the reduced row epsilon. So the diagonal has to be all 1 and everything else is 0. Those are the rules you can apply. So the first one is you can multiply any constant to any row to get a new row. You can interchange Ri and Rj, so you can just put one, you can just switch them. The third one is quite powerful, is you can multiply any row and you add to the new row to get a new row. Okay, and like I said, and I put the number right there, pretty much that's the order you have to do. So the first thing you have to do is you have to make a 1 1 1. The second thing you have to do is make a 1 2 I'm sorry, a 2 1 2, and then you make 3 and then you go to 4. Okay, so the first thing I need to do is make that -4 1. So what I can do is I can take -4, I can take the whole row, I divide by -4. So I'm gonna take or you can think of it as multiply 1/4 by R1 to get R1. So what I have is -4 divided by -4 is 1. 16 divided by -4 is -4. -24 divided by -24 is +6. All right. And then I'm just going to copy the second one down. The next thing you need to do is to make that -4 into 0. So how do we do that? Since the first one is 1, you can always multiply by the same number and add it, right? So if I take R1 and I multiply by 4, and when I add to the second one, I'm going to get 0. So I'm going to take the first one, multiply by 4. So 4R1, and then you add to R2 to get R2. So here's the result. I'm just going to copy down R1. All right. Multiply 4 by 1, and then add, so I get 0 here. 4 times -4, 16. 16, -16, -16 plus 21 is 5. Okay. And then 4 times 6 is 24. 24 plus -39 is -15. All right. The next thing I need to do is I need to make that one equal to 1. So how do we do that? We can just divide by 5, or you can think of it as multiply by 1/5 R2 to get R2. So we're not doing anything to R1. 0 divided by 5 is 5, is 0. 5 divided by 5 is 1. Negative 15 divided by 5 is negative 3. Okay, now you see why we have to make the second one equal to 0, because you can multiply anything and then you still end up with 0, right? 0 multiplied by any number is 0. So that's why it's safe to make that one 0 first. Okay, the last thing we can do is we can make that negative 4 into 0. Okay, so every time you have a 1, you can use that number to create the opposite. So when I create the opposite, I add, I'm going to get 0. So I'm going to use that 1 right there. Okay, so I'm using R2 now to get R1. So I'm going to times R2 by 4, and then I add it to R1 to make a new R1. So I'm not doing anything. I'm done with R2, so I'm just gonna copy it right there. All right, now let's multiply by 4. Okay, so 4, obviously 4 times 0 is still 0. You add 1, you get 1, right? But if I take 4 times 1 is 4, and I add that negative 4, I'm gonna get 0. Okay, and then 4 times negative 3 is negative 12. Negative 12, you add 6, you're going to get negative 6. All right, so why do we want that form? The reason we want that form is so you have, since all those are the coefficient, so you ended up with x. It's actually 1x, right? So x equals to negative 6, and y equals negative 3, and you're done.